All right, so it's going to start recording from this point now.
Okay.
So,
Okay, it shows that I shared with you, so you should be able to see it, I think. Or get an email or something.
okay, I'm opening it up. Yeah, I'm going to check my email, see if it went there. So we're supposed to draw the rock cycle.
Yeah, like on his, I just kind of watched like his prep week video or whatever, and he just shows like, yeah, like igneous rock going turn into like sediment and things like that. Are you a geology major?
I am not. I'm an engineering major.
Are you civil or are you mechanical?
I am civil.
Oh, nice. Me too.
Nice. Sweet. Okay, so I am in it. Geology week 5.
All right, sweet. I'm just gonna draw something. Did you see that?
I do see a line.
Okay, perfect.
So, and it said something about a picture, like a smart picture.
Okay, yeah, I was like looking at that, says see smart figure 1 point or 1.21 and watch the video, but there's like nothing to click on, and I couldn't find anything online about it, or like on
Yeah,
the
I can.
BYU Brightspace. I didn't see anything.
Yeah, I wasn't able to find anything on iLearn. I looked on in our textbook. I looked in everywhere. I couldn't find anything on it. So
I kind of looked in like mastering geology, maybe it's like one of the smart figures in there, but oh, maybe it is a smart figure in like the online text. Let me check that out real quick.
yeah, I looked,
Chapter
but I
one.
couldn't find anything.
Oh,
But
really?
I might have overlooked it though. If you want to check, double check, that would be fantastic. Because I do make mistakes. I'm not perfect. So
How much longer do you have to graduate?
um I've got a ways to go. I'm in my sophomore year right now, but I just chose civil engineering, just
Oh,
switched
okay.
over.
Right.
So I'm gonna be here for a little bit more.
Yeah. Well, this is my last semester, so that's
There you
nice.
go. Yeah.
Okay, it's opening up right now. Um, one.
Oh, so if you go to study area, so if you're looking at the main screen, it'll say course home, assignment scores, eText 2.0, and study area, right?
Uh-huh.
If you go to study area, and number 3 is visualize, and it says smart figure tutorials, and then rock cycle.
Okay, just a second. So, okay, so I found. Okay, so it's just on chapter 1.7. Smart.
Um,
Is it just the
yeah, it's
three?
on chapter 1.
Oh,
Yeah, chapter 1, introduction to geology, smart figure tutorials, is visualize, which is number 3. So it gives a video on it showing everything.
and that's it. So wait, go over that one more time.
All right, so how I found it, it's so you're looking at the main course home type screen right now, but you see the the tabs towards the top that say course home, assignments, scores, and then there's eText 2.0, and then study area, right?
Okay, and that's on Mastering Geology.
Yeah, that's in Mastering Geology.
Okay. Okay, just a second. Sorry, my internet's going slow right now. Okay, so course home, assignments, scores, eText, study area. You click on study area.
Yep, click on study area.
Okay.
And so bubble number 3 will say visualize, and then underneath that it'll say rock cycle as, and then smart
Okay.
figure tutorials and all that.
Oh, nice. Okay.
Mm-hmm.
Got it. You just want to just watch it, or?
Sure, might as well. I mean, it's 6 minutes long, so I mean,
Yeah.
it'll help us out.
I'll mute mine.
Okay.
So just tell me when you're gonna push play.
Can you hear it through the computer for
I
both
don't
of us?
know.
Here, I'll press play for mine, and can you hear that?
No, I can't. Oh, well,
Okay,
I'll
I
just
don't think.
get over here then.
Okay.
This is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the processes that result in each of the different major families of the rock cycle: igneous, metamorphic, sedimentary. Let's begin our discussion with this figure from the book, which shows examples of igneous, sedimentary, and metamorphic rocks. The textbook is organized according to this order. We're going to begin with igneous rocks, then move on to sedimentary rocks, and finally come to metamorphic rocks. Here's a sample of an igneous rock. It's a vesicular basalt. Basically, the way that this rock type forms is from lava. So what all igneous rocks have in common is that they form from molten rock, either lava if it's above ground or magma if it's below ground. Here's an example of a sandstone. This is a quartz sandstone such as the one shown in the center image. Sandstone may be shocked to learn. And in the case of this middle image, in Zion National Park, the structures within the sandstone suggest that it formed in a dune environment. So sand is also present in large concentrations in certain rivers and beaches, but this seems to be a dune sandstone. Lastly, here's an example of a schist. Schist is a kind of metamorphic rock, such as is found at the bottom of the Grand Canyon, as you see in the bottom center image. And the way schist forms is at the roots of large mountain belts. So when mountains are being thrust upwards into the sky, deep underneath those mountains, the rocks are getting ground around and squished and squeezed and warmed up, and it causes transformations in the rock. So schist is an example of a metamorphic rock. So again, top to bottom, igneous, sedimentary, and metamorphic rocks. This diagram in the textbook describes the rock cycle. Basically, the rock cycle is the collection of processes that result in the different major rock families, the three that we just described. Plus, we've got two sort of hubs on this rock cycle diagram that show sediment and show magma. So let's begin with molten rock, the magma in the upper left there. If it's underground, molten rock is referred to as magma. If it is above ground, it's referred to as lava. What ends up happening is as it cools down and crystallizes, it produces igneous rock. Igneous rock can come in a couple of different varieties. It can be extrusive if it forms on the surface of the earth, or intrusive if it forms below the surface of the earth. But if that igneous rock is then exposed to weathering, so the extrusive igneous rock is already at the surface, but the intrusive igneous rock is brought to the surface, then it's exposed to the forces of weathering. Basically, this means that the rock starts to break down. It turns into sediment, and that sediment is Stripped away from its area of origin, it's transported some distance, perhaps down a river system, and then it's dumped somewhere or deposited. And so those deposits of sediment often accumulate in layers, such as is seen in the lower right. And those layers of sediment can end up getting stuck together by the processes of lithification. Basically, the sedimentary grains get packed together, or they get a sort of mineral glue that holds them together, cement. And so compaction and cementation result in turning the sediment into sedimentary rock. So we've seen igneous rock form and sedimentary rock form. What about the last group, metamorphic rocks? Well, that's where we're headed next. Metamorphism is chemical and physical reorganization of the rock that accompanies higher temperatures and pressures. So when heat and intense pressure are applied to a pre-existing rock, in this case the sedimentary rock, it transforms to become a metamorphic rock. That metamorphic rock itself could then get heated up even further and begin to melt. If it melts, then it's going to produce magma again. So we return to the beginning of our rock cycle diagram here by undergoing the process of melting. Now, all the arrows in the middle of this diagram represent alternate pathways, where you could take an igneous rock, for instance, and you could transform it back into another igneous rock by following that pathway. Or you could take that igneous rock and you could metamorphose it. Or you could take a metamorphic rock and turn it into sediment, and that sediment could become a sedimentary rock, and then that sedimentary rock could become sediment, and metamorphism could occur to a pre-existing metamorphic rock, and so on and so forth. So the rock cycle actually is fairly complicated if you consider all the different possible pathways a rock could go down. The key thing to get from this is that these purple arrows represent processes, all right? So processes that need to take place in order to transform a rock from one rock type to another. So in the review material at the end of the chapter, you'll find this diagram, which basically shows sediment transformed into sedimentary rock, transformed into magma, transformed into igneous rock. And an exercise that you could go through is to pick any set of characters like these, and then go back to the rock cycle diagram and think about what pathways would have to be followed in order to make that story work. So with our story, we started off with sediment, and then that gets transformed into sedimentary rock, and then we saw melting take place to produce magma, and then cooling of that magma to produce igneous rock. So that was the story we just saw played out on the previous screen. But you could tell a very different story following a different set of arrows here. So maybe for review, ask yourself, what sort of story would I have if I had an igneous rock that then melts and then forms another igneous rock, which then gets metamorphosed? And which sets of arrows would you have to follow to make that work? All right, thank you for your attention. This has been another Smart Figure. We saw melting take place to produce magma, and then cooling of that magma to produce.
All right, did you get the video?
Yeah.
Sweet. Okay.
So we're allowed to use this figure for the drawing, right?
Yeah, basically do it just almost like copy that drawing. It says, as a group, draw a simplified rock cycle diagram.
Simplified one.
Yeah, with annotations explaining what changes a rock undergoes as it goes through one rock type to another.
Okay.
That doesn't sound too bad.
Yeah.
Okay, so all right, do you want me to draw or do you want to draw?
Either or I'm fine with. We could both draw, I mean.
Okay, sounds good. So basically just start off with magma then?
Sure, yeah. Could get a box for magma and lava, all of that. So magma forms, comes out of the earth. Let's get arrows. How do I do this? I think this is an arrow. Oh, there you go. That's an arrow.
Oh, nice.
And then put a text box right above it. Says, all right. I spelled that wrong.
I think there might be two L's. Maybe not.
There we go.
Yeah.
Thank goodness for spelling correction.
Yeah. So cooling crystallization, and then should we mention that it could be either extrusive or intrusive?
On the video it has that as the next box.
Okay.
It shows extrusive and intrusive igneous rock as the next box.
Let me put a box around that.
Let's see. So should we do pretty much, yeah, let's just copy the, could have an arrow going back that says melting. Also, let's just, okay, so, sorry, I'm just thinking aloud.
Oh, no, you're good. No worries.
Okay, so extrusive and intrusive, it can weather and, yeah, weathering, transport, deposition is right there.
Igneous rock. So that was the story we just saw played out on the previous screen. But you could tell a very different story following a different set of arrows.
Yep, weathering, transport, and deposition can turn it into sedimentary rock.
All right, I'll put a text box right there.
All right. Between igneous and intrusive, extrusive, I'm going to put arrows to melting like it has.
Okay, I'm just gonna start making text boxes for like metamorphic rock and those, and then we can just drag them into place.
Okay, yeah, I'll just make arrows then. That sounds like a good plan.
Okay.
Trying to see if I missed anything. Got melting, metamorphism, uplift. Oh, nah, I'm missing that.
All right, I think that's looking pretty good.
Yeah. Yeah, that's pretty much it. Oh, that moved. That's not where it's supposed to be. No, that's exactly where it's supposed to be. There we go. Sweet. All right.
We'll put our names down here. Okay, anything else we need to add to that?
Let me check the activity. I don't think there is. No, just Create a simplified rock cycle diagram with annotations explaining what changes a rock undergoes as it goes from one rock type to another. I mean, we pretty much have that all down. You know, metamorphic rock, igneous, sedimentary. Yeah, it's pretty much all there, all the processes that it goes underneath to change to those. So I mean, yeah, I think we have everything we need.
All right, sweet. All right. Well, is that it then?
I believe that is everything we need. All we need to do now is upload it to iLearn. I will message you a link to the whatever you call it, the video. Yeah.
Oh, okay.
Well, I should have the Google Docs link because I'm in it. But for the video, I can message it to you.
Okay, sweet. Yeah, that sounds good.
Yeah. All right, I'm just trying to remember how to do this. I think as soon as I exit out of this video, it will upload to my YouTube channel, and then I can get a link from that. So, all right, I'll message it to you through Google Hangouts. So the conversation we were having there, I'll just throw the link in there, and then if you can try it and see if it works, because last time it was set to private instead of public, so I had to change that. So if there's any issues, just let me know about it.
All right, sweet. Thanks, man.
Yeah, no problem. All right, I guess we'll talk to you next week then.
All right, sounds good.
All right, bye-bye.
Yep.